binary, you know binary, so binary to hexadecimal. Why do we use hexadecimal?
It's smaller.
Yeah, more compact and
Easy to understand.
not easier to understand.
Easy to read.
It is easy to read. Okay, because there's a really strict relationship. Every nibble is a hex digit. That's the key thing. So if you see something like 8, you know what that is in binary. If you see something like A, that's easy to know that that is 1010 in binary. Okay. It isn't good when you're looking at memory, which is when you tend to look at X a lot. If you're looking at memory and you see loads of ones and noughts, you're going to make mistakes. Impossible. Okay, and obviously that, if you've got a 32-bit value, it takes up 32 characters. If you want to display it in binary, but in hex, how many characters would it take up? 32 bits. Yeah. So slightly more compact. Right, so trivial, no dividing going on, but if we've got a binary pattern, something like that, okay, all we've got to do, starting from this side, what's this bit called at this end?
Least significant.
Least significant bit. Ooh. LSB, what's the one at the other end? It's got two names.
Most significant.
What's the other name? Sign bit. Okay, super important. Right, so whenever you're doing these, all you do, you work from this end and you take groups of 4. Now obviously I've written that down really nice, but my tip for you, because the exam board wasn't writing nice, is to block off groups of 4. Okay, and then as soon as you've got your nibbles identified, you just read it. So you read that 8 and 2 and 1 is 11. 11 in hex is B. The other one is exactly the same, so that's BB. That's it. That's all there is to it. If you're feeling a bit dumb, write down 10 is A, 11 is B, and so on. Do not be a hero and make a mess of an easy question. That is the key. Okay? Nobody cares. You don't get hero points at the end of the exam. But you do lose stupid points. Alright, so just write out a number line. I would say the same for ASCII if you get a question on ASCII and you're unsure. Or you only need to remember a couple of numbers for ASCII to work it all out. Okay, so trivial like that. If you've got a hex value, so FF, AA, somewhere high up in memory on a 64K machine. Right, so if you've got something like that, all you do is you just take each hex digit and say, right, what's the nibble then? Doesn't matter which end you start at, as long as you write them down in the right order. I tend to always work from the most significant hex digit. So FF, easy, 15, another 15, 8, well that one's easy, and then A is 10, so that's an 8 and a 2. Piece of cake. If I want to go back and do something a little bit longer, so I'll give you an example of one. You might get a 7-bit value. Okay, so 7 bits is a significant number of bits for representing what sort of data? 7 bits.
Unicode.
No, not Unicode. Unicode is 16-bit format, or 32 if you do the extended pages.
ASCII.
ASCII was originally a 7-bit code. And then you would use another bit for parity to do some error checking. So if you was given something like this, so 101, if you were stupid enough to say, oh, convert that to hex, and you went from this end, it wouldn't work. So you must always go and work from the least significant bit. So you go that 4, and then what is that implied bit?
0.
Yeah, leading 0, it doesn't have any significance. So that will be, so once I've got that identified, you can see that that's 7 and that is 5. That's hex. Okay.